Continuing on with our 6.3 lesson, we're looking at writing equations when we're given the roots. So essentially, we are given on the graph where the parabola hits the y-axis. So in this case, we'd say maybe it's at -2 and 1, 2, 3. So -2 and 3. So we maybe have a parabola that looks a little something like this. And we need to write the equation for that. We know the roots, but we don't know what the equation is. Well, we've started before where we work backwards. We have the equation and we work to find our roots. Now we have our roots, so we can just plug those into our factors. Because our factors were what we're solving that. So if we have a factor of, or a root of -2 as one of our x values, and a factor or a root, of 3, we need to find what's making these become 0, because in the end we're always adding to 0. Well, if we're looking at our -2, we need to add 2 to make that one 0. Similarly over here, looking at our 3, we need to subtract 3 if we want to make that one become 0. Now in these cases, we take away our roots that we had and just replace them with our x's. Just remember, roots were always x equals our -2 and our, our +3. So we just replace those roots then with the value of x. Now that we have our factors, we just need to get it back into standard form, which is just as simple as foiling. X times x is x squared. X times -3 is -3x. 2 times x is +2x. And 2 times -3 is -6. And it all equals 0. We're almost done here. We just need to combine our like terms. X squared, -3x, and +2x is going to be -1x, or just -x, and -6. And we need to always make sure that we set it equal to 0. So this would be our quadratic equation in standard form for a equation with roots of -2 and 3. In this case, our a value is 1, our b value is -1, and our c value is -6. Sometimes we may be asked to write a quadratic equation with roots that are fractions. That might seem a little daunting at first, but it's really no different from integer roots. Again, all we have to do is set up our fractions, or our factors, and set those equal to 0. We look at our first one, -2/3. Our second one here was 6. How do we get those to equal 0? Well, this one we have to add 2/3. This one we have to subtract 6. Again, replace these roots with x. Now that we have this form, we still need to get it into standard form. Again, it's easy as foiling. X and x is x squared. X and -6 is -6x. 2/3 times x is +2/3 x. 2/3 times 6. I want to show you that one over here. If we've got -6 over 1, that's how you'd write -6 as a fraction, times 2/3, 2 over 3, we go right across. -6 times 2 is -12. 1 times 3 is 3. -12 divided by 3 is -4. So we have a -4 at the end here. And again, that equals 0. We still need to combine our like terms. And again, I'm going to move over here to show you a good way to do that. Anytime we are adding fractions, we need to get them into a common denominator. Right now, if we look at -6 as -6 over 1, we need to get it into a denominator of 3. So we have to multiply by 3 over 3, which leaves us with -18/3. So if we look at that as -18/3 x plus 2/3 x, this is how we're combining our like terms from over there. this is going to become negative 16 thirds x. So we're left with x squared minus 16 thirds x minus 4 equals 0. We're getting so close to the end here. We have it into standard form except for the fact that our b value is a fraction. It is not an integer quite yet, and we need it to be an integer. So one quick way to achieve that is to multiply our entire equation by 3. I used 3 because that is our denominator here. So we'll multiply this by 3, this term by 3, this term by 3, and yes, technically the 0 we'll have to multiply by 3 as well. When we multiply 3 by x squared, that leaves us with 3x squared. When we multiply 3 by negative 16 thirds x, that's a negative 16x. In this case, we were dividing by 3, then we multiplied by 3, so it cancels out, and we're just left with a negative 16x. Negative 4 times 3 is negative 12, and again, it has to equal 0 times 3 is just 0. So in the end, this is our final answer. So after this, you should know how to solve different equations, different quadratic equations by factoring, using greatest common factor, and to find equations when given the roots.